Hello everyone, welcome to Unshackling Sudokus and Puzzles. I'm Kishore and I'm here to solve a Sudoku created by Richard Stolk. This Sudoku has been taken from wcpm.nl website. It is an excellent website where you can see a Sudoku or a puzzle posted each day from Monday to Friday. I will add the link to the website in the description. It's an excellent website. And this Sudoku has been rated 5 stars on the portal, which is the maximum you can assign to any puzzle, and which means that it's a really hard puzzle. I tried this Sudoku a few days back and really enjoyed the solve path, and I thought it would be good for a video. So I thank Richard for allowing me to make a video on the Sudoku. Thank you, Richard. And the link to solve this is in the description of the video. You can please give it a try and come and watch the video. Let's jump into the rules now. Classic rules apply. Each row, each column, and 3 by 3 box in the grid has digits 1 to 9 without any repetitions. And then the rules read that clues outside the grid indicate the sum of digits of a palindrome that is located somewhere in the diagonal direction of the arrow and consists of at least 3 digits. It's crystal clear. For example, let's say we consider the 8th clue given at the bottom of the grid. There must at least be a 3-digit long palindrome along this direction, the direction pointed at by the arrow, in which the sum of the digits of the palindrome must add up to 8. So for example, you can have, let's say, a 2, 4, and 2 here. And before that, I need to explain what is a palindrome. So for example, let's consider this 6L line. Imagine that there is a 6L line here and we start putting digits here. So if you read this line from either direction, 1, 2, 3, 3, 2, 1, and if you read from this direction, 1, 2, 3, 3, 2, 1. So this is a palindrome. It reads the same from either direction. And this Sudoku rule states that you must find a palindrome along the direction pointed by the arrow, which must at least be 3 digits long and which must add up to the clue. So for example, this could be 2, 4, and 2, and the palindrome is satisfied, and so is the clue. So these are the rules. With that, we'll start this Sudoku. And since I've solved this earlier, I know the exact solve path of the Sudoku, and the break-in you'll realize to this Sudoku is row 7, column 7. We know that it's part of the 8th clue because it's a 3-cell long palindrome, and regardless of whether we start from the bottom or the top, this cell always becomes a part of the palindrome. And you'll also notice that the maximum value that can go in here is a 6. If you have anything more than a 6, let's say you have a 7 here, there is no way you can form even a 3-cell long palindrome, right? The maximum you can get is a 6 here, right? So let's remember that for now. Now it's time to look at the 53 clue. What I'm going to do here is I'll start from row 1, column 1, and I'm going to see how long the palindrome must or must not be. Then I will start with row 2, column 2, and do the same thing. I'll start with row 3, column 3, and do the same thing. So let's start with row 1, column 1 first. You'll notice that it must at least be 7 cells long. The reason is, if you have, let's say, 6-cell long palindrome, starting from row 1, column 1, the maximum you'll be able to fetch is this much, 987 and 987, and that gives you 24 multiplied by 2, 48. So there must at least be 7 cells in this palindrome starting from row 1, column 1. Now, can it be an 8-cell long palindrome? You'll quickly realize that it's not possible. The reason is because it's an 8-cell long palindrome, row 4, column 4 must be equal to row 5, column 5. It's a palindrome, right? It must read the same from both directions. So these two cells must be equal, but they are in the same box. So not possible. Now let's see what happens if it's a 9-cell long palindrome. Now, row 5, column 5 becomes the middle cell, and this cell and this cell or on either side of the middle cell, so they must be equal, but they are in the same box. So again, not possible. So the only possibility you will realize that is a 7-cell long palindrome starting from row 1, column 1. And you can quickly see that this is a valid palindrome. These two can be equal. These two can be equal. These two can be equal. And this is the middle cell. So one of the possibilities of the palindrome is this way. Let's mark it in pink. The next step, let's assume that the starting cell of the palindrome is row 2, column 2. And you'll realize that it must at least be 5 cells, because 4 will give you a maximum total of 17 plus 17, which is 34. So we need at least 5. And I don't think even 5 is possible. Let's try. Let's give the maximum values. Put a 9 here, put an 8 here. This will be 8 and this will be 9, and put a 7 here. And you'll see that this is a palindrome. However, the total is maximum 41. So no way this is possible. Let's think that it is a 6-cell long palindrome. But this can be quickly eliminated, because the third cell, this one, and this one must be equal, and that is not possible. It's in the same box. Let's think if it's a 7-cell long palindrome. And that is also not possible, because this becomes the middle cell, and the cells on either side of the middle cell are on the same box, so that is also not possible. Let's consider if it's an 8-cell long palindrome. That is also quickly eliminated, because the 4th cell from either direction is in the same box again. So we can conclude that the palindrome can never have row 2, column 2 as the starting cell. Now it's time to look at row 3, column 3. And we'll need at least 6 cells, because if you have 5 or lower than 5, there is no way you can get to 53. And one more thing is, you cannot have a 5-cell long palindrome, because this is the middle cell and these two become equal, which is not possible. And 4 is obviously ruled out. There is no way you can form a 4-cell long palindrome. So it's minimum 6 cells. And we can quickly rule out 6 as well, because this cell must be equal to that cell, being a 6-cell long palindrome, which is not possible because they are in the same box. Okay, so let's see if a 7-cell is possible, and you'll realize that this is possible, this 7-cell pattern. So because this becomes equal to that, that becomes equal to that, that becomes equal to that, and that is the middle cell. So to conclude, there are 2 palindromes which are possible along the 53 direction, starting from row 1, column 1 to row 7, column 7, or starting from row 3, column 3 to row 9, column 9. And in both the cases, the common cells are these 5 cells. Excellent reduction, right? So let me remove the colors from here. So these 5 cells will always be part of the 53 palindrome, no matter what. This is a tough starting deduction, you can say. Now, the next step. We saw that the maximum that can go into this cell is a 6. Obviously, you cannot have an odd number, because the 8 clue can never be satisfied. So let's go below 6 and see. Let's have a 4 and see if 53 is getting satisfied. And for that, we'll consider the first case, which is the palindrome starting from row 1, column 1. So in that case, this becomes a 4. And I'm going to put the maximum values here. And now if you add these digits, 489 is 21, 489 is 21, 21, 21, 42 plus 7 is 49. So you are not able to reach 53, right? Now let's try using the other scenario. There are 2 possibilities for the palindrome, right? Let's try using the other one. And I'll remove these colors and put these colors in again. Okay. So we had a 4 here, and which means that the third cell from this direction will be a 4. And let's try putting the maximum values now: 9, 9, 8, 8, and a 9. Now if you add all these cells, 489 is 21, 489 is 21, 21, 21 is 42, 42 plus 9 is 53. So you can conclude that you can never satisfy the 53 palindrome by having a value less than 6, because the moment we go under the 6, 53 is getting contradicted. So this is again a vital deduction as far as this Sudoku is concerned. So which means that maximum that can get here is a 6 and minimum that can get here is also a 6. So this has to be a 6. What a deduction, guys. So this is the starting deduction to this Sudoku. Imagine what a tough deduction, right? And now the moment you put a 6, and since this is part of the 8 palindrome, we can quickly deduce that both of these must be 1 to satisfy the 8 clue. Let me put yellows there. So 8 is satisfied. Okay. Now let's look at the 4 clue on the right side of the grid. There are 2 possible ways to make the 4 clue. One is by having 4 consecutive ones, 1, 1, 1 and 1, right? This is a palindrome, but can you have this? You'll realize that this is not possible. Let's start from row 7, column 9. Obviously 4 consecutive ones is not possible because these two will be in the same box. And starting from here again, 4 ones not possible because this would become a 1, and that is also a contradiction. And you also cannot start from here, right? Same contradiction. And similarly you also cannot start from here, again not possible. So the only possibility for a 4 palindrome is to have a 1, 2 and a 1 in some of the 3 cells along this direction. Now let's see which 3 cells. If you have here, then this would have to be a 2, but that is not a 2, that is a 1, not possible. If you start from here, this will be 2 and this will be 1, but that is leading to a contradiction, so not possible. And you cannot start from here because 1 is here. You cannot start from here because 1 is here. So the only possibility is by using these 3 cells, so 1, 2 and 1. Excellent, right? Superb. So 4 is also satisfied, and we know that these are the 3 cells which are part of the 4. Now let's do some Sudoku stuff here. 1 goes into these 2 cells, and 1 in box 5 goes in these 2 cells. Okay, let's stop there. Okay, I'm just thinking here how this palindrome can work. Although I've solved it, I don't remember it exactly now. Okay, I don't think we can do anything there. Let's try looking at the 28 clue at the top of the grid. How does it work? Now I'm going to say that this too will be a part of the palindrome. The pink cell, row 3, column 3, let's mark it blue as well, is definitely part of the 28 palindrome, because as per rules, it must at least be 3 cell long, and this will definitely become part of it. I'm going to say that 2 is also a part of the palindrome, because if not, then this will be the palindrome that you can match, and you can never get a 28 from those 3 cells. 9, 9 and 8 would be the maximum, and that gives you only 26. So no way it's possible. This is also part of the palindrome. Let's mark it blue. Okay. Again, this will also be part of the palindrome, because you cannot form a palindrome with these 3 cells. So this also gets blue. Very well. Excellent. And again, you can't say that this is not a part of the palindrome, row 1, column 5, because then in that case, this will be the palindrome, right? And you'll see that this is not going to get you to 28. So 2, 2 are the maximum values, 9 and 9, and this will get you to 22 only, which is not equal to 28, obviously. So it is clear to me that this is also a part of the palindrome. And again, you can say that row 5, column 1 is also a part of the palindrome now, because if these are the 4 cells, then this gets equal to 2, and you can at max put 9 9, and that will get you 22 only. So again, not possible. So all 5 cells would have to be part of the palindrome. And this is not a 2, right? So this was a pink and blue. And now this is a 5 cell long palindrome. So obviously the second cell on either direction must be equal. So that's a 2. Now let's look at this cell. What can this cell be? Obviously these 4 digits must add up to even numbers, because this is equal to this, so 2 times something, and this is equal to that, so 2 times again something. So 2 times something plus 2 times something will always be even, so which means this would have to be even to satisfy 28. So that's 2 4 6 8, and you'll notice that 2 and 4 can be quickly eliminated, because if you have a 4 here, 4 2 2 is 8, and you'll need 20 from these 2 cells, which means both must be 10. So not possible. This will be 6 or 8. Okay, so that's the next deduction. Okay, so the next step is seeing that row 3 column 3 cannot be 6. If it is a 6, look at the 53 clue now. Now I said at the start that there are only 2 possibilities for the palindrome. One is this way and the other is this way. Now let's look at the starting way, this way. If you do that, then row 7 column 7 must be equal to row 1 column 1, but that is clearly a contradiction because 6 is already there. Now let's look at the second way. 6 is at the starting cell, again it leads to a contradiction. So it is clear to me that 6 can no way be possible for the 53 clue to work. So let's go back now. So this is not a 6, this would have to be an 8. And now let's look at the 28 clue. 8 plus 2 plus 2 is 12. We need 16 more. So it is clear to me that both must be 8. All right, let's do some Sudokuing now. This gives 8 here. This gives 8 here. Now the next step is you can deduce which way the palindrome works. If this is the way, the palindrome starts at row 1 column 1, 6 has to be here, and the third cell from here would be 8, so third cell from here would be 8, but that is clashing with that, right? So the starting cell can never be row 1 column 1, and now we have deduced that this is the only way by which the 53 palindrome can work. So you can see that how tough the deductions are. Like you have to get in depth to get these contradictions. And now we can just put some digits quickly. So that's 8, third cell, so that's 6. And for this to add up to 53, you'll notice that this would have to be 9, this would have to be 9. And that pushes the 1 here, and that would have to be a 7. So if you do anything else, you can never add up to 53. For example, you put a 1 here and a 1 here. 618 is 15, 618 is 15. You're desperately short of the 53. So 1 goes here. And anything less than 9 here will break the puzzle. For example, let's put a 8 here. 8 again, not possible. Let's put a 7 here, 7 here. 6, 7, 8, 6, 7, 8, 21 plus 21, 42, and you can nowhere reach to 53. So this would have to be 9, this would have to be 9. And now 6, 8, 9 is 23, 6, 8, 9 is 23, this would have to be a 7. Excellent. So we got 53, we got 28, we got 8. A few more clues are left. Now let's think closely. Let's do some Sudoku stuff. 8 is not here, 8 is not here. These two would be 8s. 8 is not here because of this 8. And 1 in row 4 has only one option. 1 goes here, and that puts 1 in one of these 2 cells. 1 is not here, 1 is not here, 1 goes in here. Okay, for the 11 clue, these 2 cells must invariably become part of the palindrome. Let's use green for the 11. because it's at least 3 cell long. So these two will definitely be part of the palindrome. Okay, 8 is in column 9. That removes the 8 from here. Okay, now let's look at the 19 clue at the right of the grid. I'm going to say that row 1 column 5, this 8 can never be part of the 19 clue. The reason is, if you have this 8 as part of it, it cannot become a 5 cell long one because there is an 8 already here. So at max it can only be a 4 cell long one. Of course it can also be 3 cell long, but that would force an 8 here, and that is leading to a contradiction. So you need to put an 8 here, right? And now no way you can reach the 19 cell, 19 total. 8 plus 8 is 16. So these two cells must be equal. So 1 or 2 or 2, doesn't matter. They will always add up to even, and 19 clue can never be satisfied. So it's clear to me that row 1 column 5 is not part of the palindrome. So these 4 cells must be part of the palindrome, and you can clearly say that it cannot be 4 cell long. The reason is 2x plus 2x will always be even, and we have an odd clue at the outside. So it's a 3 cell long palindrome, and which means these 2 cells will be part of the palindrome. Let's use orange. Okay. Okay. So the next thing is to see here is that notice how the 8 works here. 8 is not in this T-shaped region in box 6. So 8 has 3 options here. Now can the 8 be in row 4 column 8? It's a really tough deduction. So if you have an 8 here, now if this is the 3 cells that we are talking about, then both of these must be 6 to satisfy the 19 clue. 8 plus 6 is I'm sorry, what am I doing here? It's a 3 cell long palindrome, right? So if this is 8, we need 2 plus 9, which is 11 more, and you cannot get 11 more from these 2 cells because they must be equal. Now let's look at it the other way. If this is the 3 cell long palindrome, that would force an 8 here, and which is again not possible. You already have an 8. So you can eliminate 8 from the orange cell. So 8 is not here, and that gives 8 in one of these 2 cells, which removes the 8 from here and forces the 8 here. Excellent. Let's look at this cell. What can go in this cell? For now, we'll assume that these 3 are the cells of the palindrome. When you assume that way, this becomes 3, 4, 5, 6, and 7. Okay. And these 2 cells add up to even number because they are equal. They add up to an even number. And which means this must be odd to get to 19. So 4 and 6 can be quickly eliminated. So it's 3, 5, and 7. If you have 3 here, then these 2 must be 8 and 8, which is clearly not possible. So let's try with the 5 there. If you have 5 there, then these 2 must be 7 and 7, which is possible. I don't see any contradiction there. Let's see what happens if it's a 7. You have a 7 here, then these 2 add up to 12, so they must be 6 and 6, which is not possible. So which means that this can only be a 5 if this is the palindrome. So let's have the 5 there for now. Let's have it as a corner, or we'll have it as a center. 5 is the only possibility if you have these 3 cells. Now let's see what happens if these cells are the palindrome. I'll remove the orange from here and put an orange here. Now let's see what happens. So these 2 add up to even. So this must be odd. 1, 3, 5, 7, 9. 1 is not possible. And if you have 3, you'll need 8 and 8 here, which is not possible again. 5 gives a 7 and a 7 there, which is possible. A 7 Um, oops. 7 there gives me 6 and a 6 here. And that is also possible, right? Yeah. I think I'm muddling the pencil marks. Let go a little bit clear here. The first case, we established that this has to be a 5. Let's see the second case. The middle cell can only be odd, so it's 3, 5, 7, 9. Should I use a corner? Corner would be better. 3, 5, 7, 9. 3 is obviously ruled out because both would be 8. Okay. If I have 5 here, then this must be 7 and this must be 7, which is possible, no problem. Now let's try the 7 there. If it's 7, then this must be 6 and this must be 6, right? That is also possible. So this can be 6 and 7. If it's 5, this would be 7, 7. If it is 7, this would be 6, 6. Okay, let's see what happens if it's 9. Then in that case, this would be 5, 5, which is also possible. Okay. So these 3 cells can only be 5, 6, or 7. In the first case, it was only a 5. In the second case, you have 6 and 7. 7 is not possible because that would put a 7 here. You already have a 7 here. So this can only be 5 or 6. This cell. Let me put that there. So this is 5 or 6 only. That is nice. And let's see what happens. This was, if this is 5, this was a 7. And if this is 6, 6 plus 6 is 12. And this is 7 still. Excellent. So this is always a 7, no matter what. If you have 5 here, this is the only possibility. So 7 and 7 go here. If you have 6 here, then 6 goes here. 6 plus 6 is 12, and this still would be a 7. So this is a 7. Tough one. And 7 is not here, 7 is not here, so that gives 7 in here. 2 is not here in row 2, 2 is not here, so that gives a 2 in one of these 2 cells, and that gives 2 in here. 2 is not in column 4, 2 is not in row 4, 2 goes in here. So a bit of Sudoku to get us going. Okay, now let's look at the 20 clue on the left of the grid. Again, I'm going to say that just like I did for the 19, 8 row 5 column 1 can never be part of the palindrome. The reason is, if this is part of the palindrome, this has to be replicated somewhere. It can't be obviously done here because you have an 8 here, and you can't replicate that here. You already have an 8 here. This is the only option left to us. If you put an 8 here, then this becomes a 4 cell long palindrome, obviously, and this would be 2 and this would be 2. That adds up to 20, but there is already a 2 in there, so not possible. So this is not part of the 20 palindrome. So you have 4 cells left now, which means these 2 will invariably be part of the palindrome. Let's use a different color. Maybe orange is taken, yellow is taken, pink is taken, red is taken, blue is taken, green is taken. Okay, let's use gray. So these 2 cells will always be part of the palindrome. Now let me think here. So we do not know yet whether this is a 3 cell long palindrome or it is a 4 cell long palindrome. And if it's 3 cells, it could be this way or it could be this way. So as of now, there are 3 possibilities for this palindrome, for the 20 palindrome. I'm just looking at it now. Nice. Again, a sticky reduction, just like we did for the 8s here. Where does the 8 go in box 8? 8 cannot be here, 8 cannot be here, so there are 3 cells left for the 8. You can eliminate the 8 from row 8 column 4, just like we did for the 19 clue. 8 cannot be here. The reason is, if you have an 8 here, let's say this is a 3 cell palindrome, that is an instant contradiction. And let's say this is a 3 cell palindrome this way. So you need 12 more, so both would be 6, and that is a contradiction. So the only possibility left is a 4 cell long now, which means these two are equal and these two are equal. And that gives you an 8 here, but there is an 8 already here. So 8 is not possible there. And that puts the 8 in these two cells, removes the 8 from here and gives an 8 here. Excellent. Okay, now let's try to slowly eliminate possibilities here. For now, let's assume that these 3 cells are part of the palindrome. Let's go one by one possibilities. What can go here? This can only be 3, 4, 5, 6, and 9. But 9 is not possible, so this will be 3, 4, 5, 6, and this will be 3, 4, 5, 6. And 5 and 5 are obviously eliminated because you can get only to 10. And that means this will also be 10, not possible. So the only possibility will be 6 and 6 in this case. And this will be 6 and 6 is 12, right? 6 and 6 is 12, and this would be 8. Okay, so there is no possibility. This palindrome is simply not possible. Excellent. And which means, let's go back. This will definitely be part of the palindrome. Now the only thing to ask is whether this is a 3 cell palindrome or it is a 4 cell long palindrome. Okay, if it's 3 cell, the only possibility is this now, because this just got eliminated. Okay, let's now try with these possibilities here. This can be 2, 3, 4, 5, 7, 9, and this will be 2, 3, 4, 5, 7, 9. So let's see what happens if this is a 3 cell long palindrome. Okay, you can eliminate until 5 from these 2 cells, because if you have 5 and 5, this becomes a 10. Simply not possible. So 2, 3, 4, 5 are eliminated. So if it is 7 and 7, 14, that gives you a 6 here. And if it is 9 and 9, let's if it is 9 and 9, gives you a 2 here. Okay, not possible. Superb. You have a 2 here. So the only possibility if this is a 7 and 7 is, let's put it as corner, 7, 7 and 6. So this is the only possibility for the 3 cell long palindrome. Now let's see what happens if it's a 4 cell long palindrome. And look at these cells. It cannot be 1, 2, 8, 1, 2, 7, 8. So 3, 4, 5, 6 and 9. This will be 3, 4, 5, 6 and 9. 6 is ruled out. So 6 is ruled out here. 9 is also ruled out because 9 and 9 is 18. So we need 2 more. So both of these will be 1, but not possible. So 9 is eliminated. 5 and 5 is also eliminated because if you have 5 and 5, that gives you 10. And we need 10 more, so which means this will be 5 again and this will be 5 again, and both of these will lead to a clash, which means 5 is also eliminated. So 3, 4, 3, 4. Let's see what happens if it's a 3. 3 plus 3 is 6, and we need 14 more, so both of these will be 7, 7, and I don't see any contradiction there, so no issue. Let's see what happens if it's a 4 and 4. If it's a 4 and 4, we need 4 plus 4 is 8. We need 12 more. So this will be a 6 and this will be a 6. So that is also not possible. Excellent. So the only possibility is, let's remove the 4 and 4 as well. So only possibility is 3, 3, in which case both of these will be 7, or it's a 3 cell long palindrome and 767 is the only possibility. So in both the cases, this cell is a 7. What a deduction, guys. A really tough deduction. So regardless of whether this is a 4 cell long palindrome or a 3 cell long palindrome, row 7 column 3 is always a 7, because in the first case, in the 3 cell long one, we deduce that 767 is the only possibility. In the 4 cell long one, we deduce that only 3s can go here, which means both of these would have to be 7s, and in both the cases this is a 7. Wow, that is tough. Let's quickly go back. So this is 7, so which means 7 can't go here, 7 can't go here, so that's a 7, and that gives 7 in row 4, that gives 7 in column 8, that puts 7 in here, a 7 in here. These are all classic stuff, so I've gone quickly here. Okay, so now we know that for the 19th clue, let me remove this orange for now, that should not be there. This is not a possibility, this 3 cell one, because that forces a 5 here and a 7 here, and that is not going to be possible. 5 7 7, you already have a 7 here, so the only possibility is this one, and which means since this is a 7, both would have to be 6, and 19 is also done now. Okay, let's use some Sudoku. 6 6, that gives 6 in here. Okay, okay, time to look at the 11 clue now. Look at the 11s. It can be either this way or this way. If it is this way, let's put a green here. What are the possibilities that can go here? It can maximum go till 5, 2, 3, 4, 5, 2, 3, 4, 5. 6 will get you to 12. But if you have 5, then this will be 1, because this is a palindrome, so both would become 5, 5, 1. Oops. That's not possible. So it is 2, 3, 4, 2, 3, 4. 2 is also ruled out because that gives a 7 here. 3 gives you a 5 here, and 4 gives you a 3 here. And both are possible, right? So I'll turn it to corners now. Now let's look at the other way. Let's think that these are the, this is the palindrome. What can go here? It can maximum be 5, so 2, 3, 4, 5. 5 is again ruled out because 1 is here, 1 cannot go here. 4 is possible, 4, 4, 3. 3 is possible, 3, 3, 5. 2 is again not possible, because if you have 2 here, 2, 2, this has to be a 7 again, not possible. So the only possibilities here must be 3 and a 4 again. So you get a 3, 4 pair here. Excellent. So let's change it to 3, 4 and remove this color. So fill up this box. This is 2, 5, 1, 2, 5 and 1, 2, 5. All right. I think now it's time to approach the final part of the puzzle, which is the 26th clue. And this is probably the hardest because I took a lot of time deciphering this area as well. So look at the 26th clue. You can obviously start from any of these cells, and it's not so easy to eliminate these cells, but let's go one by one. If you start from this cell, row 1, column 8, it has to be minimum 4 cell long. 3 is ruled out because maximum you can have 9, 9, and that forces an 8 here, which is not possible. So it is at least 4 cell long, which looks likely, which is also possible, but it can also be 5 cells. Can it be 5 cells? 5 is quickly eliminated because 1 will be forced here and 1 is not possible there. So let's see if it's a 6 cell long palindrome, and seems likely. Let's first color it, maybe use light gray. So this becomes equal to that, that becomes equal to that, that becomes equal to that. So this is possible. So 6 cell long is possible. Can it be 7 cell long? Ruled out. The reason is, look at the third cell from either end of the palindrome. The third cell from this end is a 1. So which means this will also be a 1, but there is a 1 there. So 7 cell is ruled out. So only possibilities are 4 cell long and 6 cell long. Can it be an 8 cell long palindrome? Let's color it. If it's 8 cell long, the fourth cell from either direction must be equal, but they are falling in the same box. So 8 cell is also eliminated. Okay, so if we start from 26 row 1 column 8, the possibilities are 4 cell long and 6 cell long. Now let's start from the second cell. So you can see that elimination is really tedious here, but I don't think there is any other way to solve this Sudoku. So let's start from row 2 column 7. It must be at least 4 cells long. So if it is 4 cell long, 1 plus 1 is 2, and you need 24 more from these 2 cells. Not possible. Let's try with 5 cells. And that is also not possible because the second cell is 2 from this direction, which second cell is 1 from this direction, which means this will be 1. Not possible. Let's go to 6 cell long palindrome. Again, not possible because the third cells are falling in the same cell, same box. Let's try a 7 cell long one. 7 cell is not possible. And this was kind of difficult for me to look at. You can instantly eliminate that this is not possible by using the parity of the clues. The clue is even, 26 clue is even. Now, if this is a 7 cell long palindrome, look at the middle cell, it's odd. So which means these 3 cells and these 3 cells are same and they must add up to even number. So even plus odd is odd. So you can never reach to 26. So 7 cell is also eliminated. So no possibilities existing if we start from the row 2 column 7. Okay. Now let's try row 3 column 6. It cannot be 3 cell long. It cannot be 4 cell long, quick elimination in middle box. It cannot be 5 cell long because of parity. It cannot be 6 cell long because then one must be the third cell in either direction, and that is clearly a contradiction here. Superb. So third cell is also eliminated. Let's try from the fourth cell. So we need minimum 4 cells. 4 is ruled out because 1 and 1 on either box. Can it be 5? 5 means that you put a 5 looks possible here, but let's see. If you have a 5 cell long palindrome in this direction, let's use a color. So this will be 1 now. And this has to be even because these 2 cells replicate these 2 cells, so this will be even. So this has to be 4 or 6. And the moment you have 4 here, then these 2 cells must be these 3 cells add up to 6, so these must add up to 10 each. Not possible. So only possibility will be a 6 in that case. You have 6 here, these 2 must add up to 18, so 9 and 9 in both cases. So not possible again, right? So which means that even fourth cell cannot start the palindrome. I understand this is a really tedious process. So let's look at fifth cell. Not possible easily because 1 will be replicated here, not possible, and it cannot be a 3 cell long palindrome because the only possibility will be a 9 and a 9, and that gives you 8 here, which is not possible. So it's clear to me that it is either 4 cell long starting from first cell, or it is 6 cell long starting from first cell. And by first cell I mean row 1 column 8. Okay, now let's eliminate the 6 cell one. It's not possible 6 cell. Let's see how. The reason is, if it's a 6 cell long palindrome, this has to be 1, right? Both will be equal. And let's think a bit here. Look at this cell. Both of these must be equal. Now they are cannot be 1, 6, 7, 8, 9. So 2, 3, 4, 5. This will be 2, 3, 4, 5. But 2 is not possible. 3, 4, 5, 3, 4, 5. If you have a 3 in either cell. 3 plus 1 plus 3 plus 1, which is 8. So both must be 9, not possible. 3 is eliminated. Let's try with the 4. 4 plus 1 plus 4 plus 1, which is 10. And both must be 8. Again, not possible. So 4 is also eliminated. 5 is the only option. 5 plus 1 plus 5 plus 1, which is 12. So we need 7 in both of these cells, then 14. So again, not possible. You have a 7 here. So it is clear that 6 cell is also not possible. I'm sure that there may be better ways of solving this and the crude ways in which I'm doing. But anyway, this is effective, so I'm doing that. So this is a 4 cell long palindrome. There is no other possibility. And clearly you can't have 1 here, because then both of these will be 1. And no way you can get to 26. So 1 goes here. And that puts 1 in box 9. 1 goes here. This is not 1. That's a 2, 5. Let's use the palindrome now. This cell is 3, 4, 5, 9. This will also be 3, 4, 5, 9. And this one 3, 4, 5. This will also be 3, 4, 5. Now you can eliminate one by one, I think. 3 plus 3 is ruled out because that gives you 6 and you need 20 from cells, so not possible. 4 plus 4 is possible because you get to 8 and you can put 9 in both of these cells. 5 plus 5 is ruled out. That gives you 10 and you need 16 more, so both of these will be 8. So 5 plus 5 is ruled out. So only possibility is 4, 4 and 9, 9. Superb. So we're finally getting close to completion. And that 4 gives a 3 here, gives a 4 here. 4 is not here, 4 is not here, that gives a 4 here. Column 8 can be pencil marked. So the palindrome of the 11 cannot start from this cell, because then that puts a 3 here and you cannot get to 11, which is, that's equal to 10 only. So the palindrome must be this way and 4 and 4 must be equal. So 4 plus 4 plus 3 is 11. So we are satisfying the palindrome. And now in row 5 there is only one place for the 4, and 4 in row 2 has only one place now. 4 in column 6 goes here, and 9 in column 9 has only one cell, goes here. That gives a 3, 6 pair here. That means this will be 2, 5 for the box. Still hard. Look at the 20 clue. It cannot be 3 cell long palindrome this way, because that would force a 7 here. You can't have 7. So it's clear to me that this is a 4 cell long palindrome, and that means second cells must be equal. So this is 7, and that puts the 7 here. That fixes the 7 in row 1. That pushes the 2 here. 2 is not here, 2 is here. So 2 goes here. So that's a 5. That's a 2. That's a 2. That pushes the 2 here. That's a 2. That gives a 2 in here. So we get a 2, 4 pair in column 8. So 8 gets pushed in here. This is not 8. And that fixes the 8 in box 5. That fixes the 8 in box 6. So these must be 3, 5. And these must be 3, 5 in box 5 as well. And 3, 5. So this will be 3, 5. And look at row 3. This must be 3, 6. And we can complete this palindrome, right? 20 clue. 14. It adds up to 14 already. So this must be 3 and this must be 3. That gives 5, 3, 5, 3, 5. 3 gives 6 here. That gives 3, 6 here. Column 5 can be completed, must be 5 and 9. That's resolved. 5, 9, 2, 5. This is a 2-4 pair, right? This is a 6. And that completes column 4. That completes box 5. Completes column 1. This can be finished. 3, 4, 5. Can't have 4, 5 here, so that's a 3. That's a 4, 5 pair. This will be 6 and 9. And 2 can be fixed in box 7, so that's a 2. That's 6 for the column. That's a 9. That's a 6. Row 8 can be completed. This is a 3. And 1 in row 7. Only one cell left. One has to be here. And 2, 4 can be fixed. 2, 4, 4. This is 4. This is 5. That's 5. That's 9. Oof, 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 oof. What a hard puzzle, guys. What a hard puzzle. This could have been even 6 stars. A really, really tough puzzle. There are 2 main deductions which define the Sudoku, guys, and in which people tend to get stuck a lot. The first one, which I think is tough, is seeing that 8 cannot go here. That is a really tough one. We deduce that 8 must be in one of these 3 cells, and with the help of the 19 clue, we deduce that 8 cannot be here, right? And with the help of which we deduced 8 to be in these cells, and that got an 8 here. The second most tough deduction was the 20 clue. Regardless of whichever palindrome you take, 7 must be in row 7, column 3. That was the second most toughest deduction, if you ask me. The rest of the things usually follows, but they were also hard. But these were, according to me, the most defining points in the Sudoku. So hope you had a great time watching me solve the Sudoku. I really enjoyed the Sudoku. Please let us know your thoughts in comments, and do become a patron of the channel. We are hoping to provide rewards soon, so please become a patron. We have already posted some rewards, so consider becoming a patron of the channel. We'll really appreciate that, and it will go a long way in helping us to sustain the channel. Thank you for watching. See you soon. Bye bye.